All right, what's up, guys? Hopefully, we're hanging in there in this remote environment. We are going to take a look at the last section in this chapter today, and then we are going to begin to prepare to take our Unit 6 test. So we're going to try to get that in as well before the end of this week. All right. So we've been talking about systems of equations. We have looked at three ways in which we could solve a system of equations. Right? We could graph it. We could use a method called substitution, or we could use a method called elimination. And in each of those methods, the ultimate goal was the same. We were trying to find that point of intersection, that ordered pair that was shared between the two equations. And as long as the lines weren't identical or parallel to each other, there was one solution that we could find. All right, so today we're going to continue that thought process, but then instead of a system of equations, we're going to look at a system of inequalities. Okay, so remember, an inequality is not necessarily just the line, but it's also what's greater than or what's less than that line as well. So remember, we did this, we shaded either above the line for greater than, we shaded below the line for less than, and then the last piece was whether or not there was an equal to in that inequality. And so if there was an equal to in the inequality, our line was solid. If there was a less than, or excuse me, if there was a just a less than or a greater than, then the line was dotted. Okay, so we're going to need that information as well. We're going to take a look through a couple of examples, and then you will have an 8-question form that goes along with this. So in the first part of the form, they'll be asking you to identify the two inequalities that are in the system. So you'll need to be looking at that sign is really going to help you, and then obviously your slope and your y-intercept. And then they'll be asking you to identify some ordered pairs that work in each of the systems as well. So today we are going to take a look at how do I solve, number one. Number two, what does maybe a no solution look like? So ultimately, maybe something where there is no shading that is shared in common. Okay, an all solution may be shading that covers your entire screen. And then we'll look at like this real world piece, and it's going to kind of be tied into the idea of what you might need to do if you're ever interested in applying for National Honor Society down the road. All right. Okay, so if you take a look at these 4 questions at the beginning, I'm not asking you to do anything with them, but I'm just asking you to stop for a second and think what might be the best way you would solve one of these. Okay, maybe you look at them and say, man, I would graph those. Maybe because they're in y equals mx plus b, or maybe because Desmos is one of your best friends, or maybe you'd look at them and say, um, I'd substitute in this situation, maybe something like question 3 or 4, because I see a single variable down here at the bottom. All right, I see this single x value right here. Maybe I just move those y values to the other side and substitute into the other equation. Or maybe you take a look at one of these, something like this one up here and say, well, maybe I'd multiply this entire equation by 2, giving me 8x minus 4y equals 12. And then when I bring this one over, you may look at those and say, now I'll add, and those will cancel each other out, giving me 14x equals 28. So x is equal to 2. Okay, maybe something like that. So, just stop for a second and think about how you would solve each of these considering the way they're set up. Okay, so whether it's graphing like the first one, or whether it's elimination like the second one, or maybe it's substitution like the third or the fourth. So kind of keep those in mind as we're moving forward. But today, can I solve a system of inequalities? And then can I apply that to be able to find solutions? All right. So what is a system of inequalities? Well, we're going to see it here in this first example. All right, we're going to look at 3 of these before we try to apply and put it together. All right, so if we just stop for a second, we think about this first one. Okay, already in y equals mx plus b, shouldn't be that difficult for us to set up. It's got a y-intercept of 2, and it's also got a slope of 2. So up 2 and to the right 1, or down 2 and to the left 1. Okay, now the part we really got to focus on is the inequality symbol. All right, that symbol right there. What does that symbol tell me? A less than. Okay, so is that dotted or solid? Should I be shading above or below? Hopefully you're telling yourself that's a dotted line. And because it is less than is below. So we are going to be below that line. Okay, so there is my solution to the first inequality. Okay, anything that is over here. Okay, that would be this first one. Now, in a system, we have to have more than one. So here's our second one. It has a y-intercept of -3. All right, and has a slope of -1, negative down and to the right. Okay, or up and to the left. So anything along this path. Now here, this one has an equal to in it, so this line is not going to be dotted. This line is going to be solid. All right. And I'm looking to shade above. So what is above the blue line? That would be this stuff that is up here. This is above the blue line. Now you'll notice when I color this here that the blue and the yellow will turn green. That green is going to signify for me my solution area. Okay, so with a system of inequalities, it's not necessarily about the point that they share in common, but rather the area that they share in common. So in this particular case, anything that is in the green is a solution. Now be careful here because remember the red line is dotted. Okay, so anything on the red line is not a solution. Hear that again. Anything on the red dotted line is not a solution. However, stuff on the blue solid line is a solution. So my question to you right now would be this point right here that they share in common, is it a solution, yes or no? And you should say, no, it is not. Okay, because they're not both solid lines. So if you were looking for solutions, you would want to find things that are either on the blue line down here that's touching the green, or anything that's obviously solid in the green is a solution. All right, so what's shaded in yellow is a solution to the first, but not the second. What's shaded in blue is a solution to the second, but not the first. The stuff that is in green is a solution to both, and the stuff that's in white obviously is not a solution to anything. Okay, so looking at these two kind of quickly, just so you get an idea of what's going on here. Remember, you don't always have to solve y equals mx plus b. That's standard form right there. Okay, we can graph out a standard form, especially when all of our numbers are divisible by each other. So for example, in this case, if we thought about making the y value turn into a 0 for a second, that would tell us that 2x is equal to 4, or that x is equal to 2. Okay, so there's a value right there. All right, or if we cover up the x's, it would say that y has a value of 4. Okay, that is an equal to in this situation, so that is a solid line. Now, before I do that, it might be nice to just get a couple more ordered pairs. So create your slope. That's up 4 and to the left 2. So up 4 and to the left 2, or down 4 and to the right 2. All right, so there's that line, solid line. Now, here's an old trick if you remember this one. I can't really just look at that sign right now. I'm going to have to plug in an ordered pair. So if I plug in the ordered pair 0 and 0, if I put a 0 in both of these spots, is 0 greater than or equal to 4? I would say no. So since 0, 0 is over here on the left side of the line, and that was a no, then I'm going to want to be on the right side of the line. So what I'm doing right now is I'm creating solutions to anything in the first equation. Remember, this is solving or graphing by its standard form. Sorry, okay, and not necessarily y equals mx plus b. Now, if I take a look at this one here, I can do the same thing. If I cover up y for a second, I look at that, it says x is -4. So 1, 2, 3, 4 units to the left on the x-axis. If I cover up the x and I just look at the y, it says 2y and -4, so that means y is -2. So there's that one. This inequality does not have an equal in it, so therefore it's going to be a dotted line. But again, if I just extend the slope so I can see the path a little bit better. 1, 2, 3, 4, there we go. So this line is dotted. Okay. And I'll test the order pair the exact same way. So if I take 0, 0 again, so 0 here and 0 there, that would say 0 is greater than -4. That's true. So because 0, 0 is above this line, and that did work, I will also shade above the line. So that's all this area here. But again, the yellow and blue will make green. So the green is my solution area to the whole problem. All right. So you can see that my solutions are over here. So I can graph out of standard form if I want to. I can graph out of y equals mx plus b. I just have to be careful that I make sure I understand where my shading needs to take place. So in this particular case, plugging in an ordered pair using 0, 0 can easily help me do that. All right, we're going to look at 2 more and then we're done. So here's number 1. Now you look at these 2 of the last 2. Look right there. Same slope. Same slope means what? If you're thinking to yourself, same slope should indicate to me that I am talking about 2 lines that are parallel to each other. Okay, so if we think about parallel in a system of equations, parallel means no solution. That's not always the case here. Okay, so if I graph this, there's a y-intercept of 1, slope of -3, down 3 and to the right 1, or up 3 and to the left 1. The symbol here is greater than or equal to, so that means solid line. And greater than is above. Above is over here. All right? So anything over here. All right, so there's number 1. Now you can already start to see that just based off of this originally, I mean, those are all solutions over there. So don't think like a system of equations where we might not end up with a solution. We very easily can end up with a solution when we're talking about shading one side of this line. Now, number 2 starts down there at -2, but it also has a slope of up 3 and to the left 1. So you can see that these lines are going to be parallel to each other. Okay, so there's my second line. And again, this one is also greater than. So greater than would go the same way. Now I'm going to shade this tiny little strip in between here, but I also have to shade anything over here. Okay, so what's a solution this time? Well, it's anything bigger than the first line, because notice all of them share this area in common. All right, so that one kind of looks something like that. Now, if we just back this up for a second and go back here to the original, if, and I'm not saying this was the case here, but if this inequality had been a less than or equal to, if they had gone that direction, I would have been shading below this line. Okay, you can see in this situation that if I had shaded this way, well, where's the green now? There's not any. Okay, because now they went away from each other. Or if the blue line was shading above and the red line was shading below, okay, if it had looked something like that, like if this was gone, and if we take that one away over there, can I get that to go away? Maybe one more time. Okay, you know, what if the red line was shading below? That would have been everything over here. And what if the blue line was shading above? That would have been everything over here, right? You can see now that the only thing they would have shared in common would have been that tiny little strip in the middle. So don't think that just because 2 lines are parallel that they don't have a solution. They can have a solution. You just have to be careful when you graph them what that may look like. So if we go all the way back here, sorry, this looks all crazy. All right. The way this problem reads right now, because they're both greater than, is that this is our solution. Okay. Anything above that's in the yellow. Okay. That is our answer to this one. So just giving you some different possibilities of what you potentially could run across. All right, last one. Take a second here. Everybody loves a good word problem, right? A college service organization requires two things of their members. Number one, you must maintain at least a 3.0 GPA, and you must volunteer at least 10 hours a week. So here's the question. Can I define a variable? Meaning, can I lay out what should go where? What's going to be defined by my GPA? Well, you can see just by looking at the graph, I've kind of already defined my GPA to be the variable of X. Okay, can I write a system of inequalities? A system of inequalities means that I have to have more than one. So in this particular case, I am going to have two. One to represent the GPA down here on the x-axis and one to represent the volunteer hours on the y-axis. Okay, and then lastly, can I graph this system? Can I show the solutions? So let's start with the first one. And we'll go with this yellow because we'll highlight that one in yellow. Okay, the college service organization requires that its members maintain at least a 3.0 GPA. Think about that phrase, at least. Could you have a 3.0? Yes. So in this particular situation, would look something like that. At least a 3.0 GPA. Okay. And then secondly, volunteer at least 10 hours a week. Well, volunteer hours are over here on the y-axis, so volunteer at least 10 hours a week. Now, because both of these symbols involve equal to's, I know my lines are going to be solid. And lastly, they're both greater than, so they're going to be shading above. Now, I've kind of already marked these out on the x-axis because our GPA, as we all know, you can have anywhere from a 0 up to a 4.0 GPA. So we want a 3.0 GPA or greater. So that is going to be, notice that in this first equation up here, there are no y's, so therefore we are not going to cross the y-axis, so it's just going to be a vertical line. Okay, and we want things to be greater than or equal to 3, so that's going to be anything this direction. Okay, so we'll color that one in yellow. Secondly, on our y-axis, we must volunteer at least 10 hours. Okay, so if we just count all these by 2's, again, there's only a y variable, no x, so that's going to be a horizontal line going like that. And we want to be greater than or equal to 10, so that's going to be anything that's up here. All right, so we get something that looks like this. All right, and again, we end up with ourselves like 4 distinct areas. Okay, so my question to you would be like, what do each of these areas represent? Can you visualize that? Like, obviously, these are the people that the service organization wants. Like, this is the area that's doing both. They've got the grades and they've got the volunteer hours. Okay, but what's over here in the yellow? What are these guys? All right, well, they're people who have the grades but don't have the volunteer hours. So grades are good, volunteer hours are bad. Well, what's the blue area? Well, these are people that have the volunteer hours, but they don't have the grades. And then what's this area down here that doesn't have either shaded? And unfortunately, those are people who don't have the grades and don't have the volunteer hours. We do not want to be in this area whatsoever. Okay. We definitely want to make sure we're at least maintaining one of these areas, but obviously the green area is the people who get both. Okay, so here's kind of a question that follows that same idea, and then we will be done for today. All right, the senior class is sponsoring a blood drive. Some of you guys next year will be able to do that. Okay, when you guys, I think we have to be at least 16 years of age in order to give blood, I think, here at our school. Anyone who wishes to give blood must be at least 17 and weigh at least 110 pounds. Okay, which one of these four fits that scenario? You must be at least 17 years old. All right, there's one requirement. Must be at least 17 years old. And requirement number 2, you must weigh at least 110 pounds. Now, just like before, those inequality symbols, at least, would both represent a greater than or equal to symbol. So we want to be above in both situations. Well, this one's not showing above in both situations. In fact, it's showing below in both situations, right? This one here is showing above in one, but below in another. That's no good. This one up here in the top right is showing above for the weight, but below for the age. That's no good. Okay. These guys over here are showing above for the age and above for the weight. All right. So a system of linear inequalities. Got to be able to graph the inequality either in standard form or y equals mx plus b. And then secondly, you must be able to correctly identify the symbol. Should my line be solid or dotted? Should it be shaded above or below? Okay, remember, you have an 8-question form that's going to go along with this, and they work in sets of 2. So identify the system and then find solutions that fit. If you guys need anything, don't be afraid to reach out. Have a great day.